here we are for this webinar, Careers in Fusion Energy for Engineering and Project Delivery. This webinar is being put on by the University of York and the UKAEA Foster Programme in collaboration with Tokamak Energy and Amentum. Next slide, please. So that cover image that we had on the title slide is the same one as on the right there. So that is the construction site of ITER in the south of France. So that is a large international collaboration to build a fusion experiment. So the fundamental question that we're addressing in this webinar is how do we get from fundamental science to construction and delivery? So we've got the fundamental science on the left there studying plasma turbulence. How do we turn that into the construction site of ITER or some other future fusion power plant? And the answer is it's through engineering and project management. So fusion is, the industry has kind of reached this point where we're now transitioning into this more engineering and project delivery phase. So we need the people to support that. And that's the purpose of this webinar, is to talk a bit about the career opportunities that are available in this space. Next slide, please. So we've done the housekeeping, so we can skip that one. Next slide. Yeah, it's not moving for me. Yes. Okay. So here's a little bit about me. So I did my first degree in physics at the University of Nottingham, then worked in engineering consultancy for a while, working on mainly civil and naval nuclear fission, but also various other things, planes, trains, all sorts of other things as well. I then worked in the oil and gas industry for a year, and then came back to University of York this time, where I did the MSc in fusion energy, followed by a PhD in plasma science and fusion energy. And since graduating from my PhD, I've been working for the UKAEA as a senior engineering analyst and capability lead for electromagnetic load simulations. And since last year, I've also been an industrial visiting academic at the University of York. And some of the projects I've worked on include electromagnetic loads for STEP, digital twinning and virtual qualification under various project names, and more recently, an electromagnetic validation project. Next slide, please. So what is fusion energy? So I know there's lots of people in the audience who will be aware of this already, but some won't. So I'll go through this briefly as well. So basically, fusion is a new power plant technology that's currently in development. The idea is we're going to fuse hydrogen nuclei, and that will release the nuclear energy stored within the atoms. And to do that, we require a temperature of 150 million degrees C. And at that temperature, the fuel is a plasma, which means it responds to electric and magnetic fields. So one way of doing fusion is what we call magnetically confined fusion, where we use multiple magnet systems to shape and control the plasma. Next slide, please. So fusion is really important right now. And to give you an idea of the scale of it, I've got a few stats on this slide. So according to a report from the Fusion Cluster in 2023, there is approximately 2,400 people directly employed in the UK fusion industry. So that means working for an organization whose primary purpose is fusion. There are other people in the supply chain as well, working for manufacturing companies and consultancies and things like that. And the UKAEA Foster Programme estimates that we need 2,000 to 3,000 new individuals to join the workforce by 2030. So basically, we're going to try to approximately double the size of the industry in 5 years. So that's quite a lot of growth that we need, hence this webinar to try to get more people involved. But this isn't just this isn't just a dream that we want to do this. The government are really bought into this as well, the previous government and the current government. So there's a lot of money going into fusion at the moment, so we can actually make this a reality. And there's been good progress over the years. This is kind of the reason why it's so important right now, because we're getting really close to actually achieving fusion. So there's this big push to get it on the grid. Next slide, please. So the main message that we want to get across today is the jobs in fusion. It's not only plasma physics. So for a long time it was because you need to understand the plasma physics to be able to um, you know make a viable fusion power plant. But we've got enough understanding in that now. We need a lot more work on the other side of things like engineering and technology and computing. So there's just some ideas on the slide there of a range of different jobs. There's many more that I couldn't fit on the slide as well, but that's just to give you an idea of some of the things. And the next slides, please. And as well as all those technical things I had on the previous slide, we also need project managers, people managers, business managers, technical managers, health and safety managers, site operations people, people working in innovation and commercialization and tech transfer, and all the normal support functions that you would need in any organization. So there's definitely a wide range of different things that we need people to do. Next slide, please. Okay, so now we are introducing our speakers. So hopefully their presentations will give you a flavor of the different um, roles that are available. So later we'll hear from Richard from Tokamak Energy, Ciara from UK Fusion Energy, seconded from Amentum, and Ricardo from UKAEA. But first we will hear from Sarah Ridder, and we'll hear about her varied career in the public sector that has led her to now being the head of portfolio management office at UKAEA. So over to you, Sarah.
Thank you. I'm just going to, oops, let me just give me a moment to get my slides up, everyone. Okay. Perfect. So hopefully you can all see that now. Do shout if you cannot. Thank you for the intro, Steve. So yeah, hello everybody. I am Sarah Ridder, Head of Profession here at UKAEA, Head of Profession for Project, Program and Portfolio Management. What I'm going to do today is I'm just going to broad brush speak you through my experience, but also how I landed in Fusion. How did I get here in the first place? So as Steve mentioned, I have been public sector my entire career. I'm a fellow of our professional body, the Association for Project Management, which is the professional body here and internationally. And I've also got the certificate in company direction from the Institute of Directors. So thinking at that portfolio level, organizational level, how everything fits together, how you can kind of, especially in the context of fusion with an emerging energy industry, what might the future look like? But I mentioned that I wasn't always fusion. No, I was not. Before here, I did a whole host of things, and that's part of the fun of working in project management, actually. I have worked on projects that have been leading building film studios for the Mayor of London, railway infrastructure, skills, investment portfolios. But I stumbled, funnily enough, across UKA when we relocated to Oxfordshire, and I've never really looked back. So that was a good 7.5 years ago. Steve did a really, really good job of explaining what fusion is. Within UKAEA, we are the national lab here for fusion on behalf of UK government. I always like to describe fusion as trying to put the sun in a box. In terms of a new form of sustainable energy, that is a phenomenally technically difficult thing to do. So when you talk about pushing the bounds of science and engineering, it really does blow my mind what we've achieved and also what there is still to do. It's a very exciting kind of industry or emerging industry to work in. Now, interestingly enough, why is the UK government investing? Why is there now a race to the commercialization of fusion internationally? Well, that's very much linked in part to the green energy agenda becoming more kind of sustainable, which is a massive win from my perspective and many's perspective, but also a financial perspective. It's kind of touted at being a multi-trillion-dollar industry globally. So that, in terms of making sure it's commercially viable, is important as well. I did want to kind of talk to you then about what does a career in fusion look like? Well, for one of the project professionals on the ground in the weeds delivering, I've kind of spoken briefly there about my earlier career. It might be delivering one of our major programs, or as you're going up through your career, acting as the assistant project manager on there. But I think to be a project professional, kind of a top tip from me, and the tip that I give as head of profession and in previous lives, is we can teach people the technical skills of the project profession, but what really extrapolates someone's career in the profession is the soft skills. If you find you're listening to this webinar and you think, oh my God, I'm great at all that stuff, or you're interested in all that stuff, if you find you're just naturally you're quite natural in things like leadership, negotiation, in particular stakeholder management, then that's good. Now, those things to you, for some of you might think, oh, I don't know. But I tell you what, when I was in university, I was really good with people. And actually, that bridging, that kind of moment of transition into the profession, that was the kind of key thing. Those soft skills were actually what led me to this profession. So I think as head of profession, some of the things that you'll find me doing on a kind of week to week basis, it I'm in a much more strategically advisory role now. So I sit on, actually, this Liberty is kind of co-doing today. I sit on a number of our sorry, not Liberty Foster. I sit on a number of our major program boards as an advisor. So Liberty, which is one of our high risk kind of first of a kind programs, 200 million, that's looking at one of those final jigsaw puzzle pieces of fusion that we don't quite yet know, but we need it for fusion to work. I sit on the Foster Programme Board, which again is that kind of skills pipeline piece that Steve spoke to. Other days, you might find me sitting down with my counterpart in UKFE, which is our sister organisation, a private company we've set up on behalf of the Crown and Treasury. Advising them on kind of mega. Theirs is different. They've stepped up into a mega programme delivery landscape, and you'll hear from some of them later. Equally, I get involved in what we call red team gateway reviews. So I go in and I kind of step in at those key moments in time where on projects you need to look backwards and forwards and kind of ask those questions. Is this still good use of public money? Is it still kind of delivering the kind of something that is fit for purpose at the end, or has something happened globally or nationally that means that we need to pivot that project or program? And equally, sometimes that results, and actually something I'm just coming out of at the moment, in me stepping in and doing deep dives and actually doing strategy resets of some major programs. And then there's a whole host of other stuff I've said there, but I also spend some of my time speaking with other organisations. I find with the project profession and a lot of the enabling function professions, kind of finance, HR, etc., you need to not just look inside, but outside at the profession more broadly to make sure that you're kind of keeping that rhythm of good practice. I wanted to kind of talk for a minute about how did I end up in fusion. Now, interestingly, I'm sitting here, and when if I was to go back to this slide, you might be sitting here going, woof. And I actually, the first time I started presenting, I used to look at the slide and I used to say, oh gosh, I never thought I'd be one of those people. That's quite a mouthful. But actually, that's not how I always was. It's taken me years and years to get here. But this is kind of what my career journey's looked like. And in particular, something that I'd highlight in this is my career journey's been really organic. I didn't kind of have a very clear picture when I left university of that's exactly where I want to be in 10 years' time. Interestingly, if you go back before university, which is why there's a sweet shop on there, I found a piece of paper in my mum's house recently, which was a drawing of me about 8 years old saying I want to be a sweetie shop when I grow up. Then, as a teenager, a professional ice skater, because I was quite good at ice skating, then something to do with the German language. Now, when I was in my late teens, I kind of had an interest in environmental science, and that was kind of a starting stepping block into what became my career. So I went to the University of Manchester, did environmental science. I was approached to do this is going to sound a bit crazy to some of you on the line. I was approached to do a PhD in atmospheric science, but actually I wanted to go out into the world and actually just find my feet and figure out where did I want to specialize? So I declined it. And that's what I did. I went on a graduate program, and I didn't even know when I left university what project management was, by the way. Didn't know it, hadn't heard about it. And I landed in an organization in Scotland, and about 6 months in, the way that I got into project management was they said, we need to kill off this project. It's not working, but the PM's just moved back to Australia. Can you quickly tidy it up and kill it off? And I said, yeah, sure, if you give me some training on what that project management thing is. Weirdly, that was my stepping stone into project management. It was a £500,000 project, and actually it was a really good one. So I actually brought it back in line with good delivery, and we went on to deliver it. Now, interestingly, beyond university, what you can see there on the top is kind of that rhythm of how I've gone on through my career from a junior PM through to kind of more delivery, large scale investment leadership roles, right through to today where I'm in a senior leadership position. But what's sat underneath that as well, which is kind of that nice little second line, is the different qualifications I've done through my career. So there's been things that I do that helps me and other organisations speak the same language within the profession so that it is more transferable. And that's really important for Fusion because we look to adjacent industries and we look to kind of that wider pool to make sure that we can bring people into Fusion, because the numbers that we need for skilled people in Fusion is large. It's doubling, as Steve said. I wanted to take a moment also to quickly highlight away from work. So I am, as I said, a human being. For those of you looking at that first slide going, oh, crikey. You know, I'm a family, I'm a mum, I've got my husband as well, and we've got 2 young daughters who are 4 and 5. I'm very much a mountaineer. I've scaled some of the kind of main mountains around the globe, Himalayas, Alps, etc. I've had to put that on ice, so to speak, for a little bit while I've got a young family. And I'm very much into board games. But, you know, I think it's important as well, by the way, to have that nice work-life balance. That's why I kind of bring this into the mix, just to make sure that you've got that kind of nice sense of yourself. And that's it from me. I will hand you over.
Okay, thank you very much, Sarah. So next up we have Richard Thwaites, who has previously worked in the synchrotron industry and now works as a mechanical design engineer at Tokamak Energy, a UK private fusion company. So Richard will be talking about his career, an example fusion project he has worked on, and the skills required to do a job like his. So if you are ready, Richard, please take it away.
Thank you very much. Like Steve said, my name's Richard. I work at Tokamak Energy. A bit about my background. I came up through the apprenticeship route with a small company called FMB. They're now called XDS. And they're from a synchrotron company, which is like high powered X-rays. The benefits I had from that was because it was a small company, you kind of get thrown in at the deep end. And so from a very early age in my career, I was working on small projects, which are like less than 10K. But then by the end of like the 6 years or 7, 8 years I was there, I was working on projects that were like hundreds of thousands of pounds. From there, I moved on to Diamond, which is the UK synchrotron, where I became, got my bachelor's, became an incorporated engineer, then got my master's, and then became chartered. And then I ended up at Tokamak Energy, and where I've been working on fusion, superconducting magnets, and the diagnostics. And I've also been working towards my fellowship. Why did I go into fusion? So fusion's got a lot of problems, and as an engineer, I like problems because it means there's something to solve. It was also not too dissimilar from the science and synchrotron world that I've grown up in, so it wasn't that much of a risk moving from one sector to another. Also, it's quite a nice thing to say when someone goes, "Oh, what do you do?" So I design nuclear fusion reactors. As has been mentioned before, there's now a race to fusion, and that means there's money behind it, so they're willing to pay for equipment that you need, whereas in some industries, like they'd rather have you sit there doing lots of work rather than letting the PC, rather than buying a nice PC that would get that work done faster. A nice little example of a project that I've been working on is a HTS pulse transformer. And like any transformer, it steps one current to another, and obviously you just trade off the voltage. Now, why would you need a HTS one? When you're working with, HTS is high temperature superconducting. So when you're working with high temperature superconducting magnets, they have a very, very low resistance. And when you're trying to measure that, if you're using a normal transformer, there's a lot of resistance in that transformer, and it's very hard to differentiate the difference in the circuits. So you need a HTS one. So we've got the resistance in our circuit is around 30 micro ohms, which means that would be lost in the noise of a normal transformer. We went from hand counts to prototype, which is one of the modules that you can see at the top. We then tested that said module, and then after it proved itself, we then bolted 5 or 6 of them together, and that gave us sort of a 10 kilowatt output. I've been asked to talk about the skills that I think are important for the industry. And it kind of mirrors exactly what Sarah was saying, is communication is key. Not only are you trying to get information from people, but you also have to be able to pass that on, whether it's talking to the key stakeholders or passing that on to technicians. And it's not necessarily just talking, but how you write your documentation, how you schedule the meetings and minute everything, so everyone knows what they need to do as and when. Like in most engineering topics or project management, documentation is key. So you've got your V diagrams in systems engineering. It's like the why, how we're going to do it, how we're going to test it. Does it meet what we wanted it to do? That's very important. And like I said in here, it's not just the what you're trying to do, but why. So when you come back or someone else is trying to catch up on the project, it's easy for them to catch up. And it's also easy for someone from outside perspective to look in and reflect. And obviously, I'll try and move that. And plate spinning, you never just got one thing to do. And if you do, you've got a very easy job. So it's not just sitting on the critical path, but making sure that everything else is catching up with you. And I think all of these transfer from engineering to project management or vice versa. Maths. So a lot of people start diving into CAD or analysis before they've done basic calculations. And to me, you can always write off a design quite quickly just by looking at physics and doing some basic calculations. Not to mention that then feeds into your analysis, because you can do some basic bending calculations or current flows. And then from that, you'll at least have the ballpark. It doesn't have to be too accurate, but if your calculations say that you should have, I don't know, 10 megapascals in stress, and your analysis is saying you've got 1 million, you know that something isn't quite right. Whereas if your calculation said 10 and your analysis said 15, you're like, well, that's in the right ballpark. Knowledge and research. I added research in there because nobody knows everything, and no one will expect you to, but you need to understand it and know where to go or how to do your research and who you can go to, because no one will ever, everyone's always there to help. And even though there's not always a standard to fall back on, sometimes you just have to think of what the standards are trying to teach you, and then just take the spirit of that. Leaning on to the same thing as accountability and leadership. It's in my early career, I always thought that it was my job to fix everything. And there's many times where I jumped in the deep end and basically I just drowned. But it never hurts to go to someone and you're like, look, this is my problem. This is what I'm trying to do. Does that make sense? And that was just an important thing that I thought I'd share. It's like, no one will ever be upset that you have a problem that you can't solve. And at the end of the day, everyone's working together in the same company for the same goal. And well, that's me, but we're going to save the questions to the end. So thank you for your time.
Okay, thank you very much, Richard. So next up we have Ciara Fox, Materials, Data Integrity and Database Lead at UK Fusion Energy, seconded from Amentum. And Ciara will be discussing her career and introduction to Fusion, followed by some materials data management for STEP. So, Richard, if you could stop sharing. And Ciara, I believe you're trying to get your sharing set up. So that will be coming on shortly. Yep, here we go. Okay, over to you, Ciara.
Thank you very much. I hope you can see my slides okay. So I'm Dr. Ciara Fox. As I said, I'm the Materials Data Integrity and Database Lead at UKFE, but I'm actually also employed by Amentum, so you'll see their logo across my slides. So I'm here as a secondee at Amentum. I'm a principal material scientist. So first of all, to tell you a little bit of my career and how I got to where I got to. So actually, even before we get onto what's on the slide, so I did my undergraduate degree at Manchester University in chemistry, so I didn't go into materials straight away. And essentially how I ended up in materials was I did a master's project that looked at nano-oxides for PWRs, and they were supposed to be representative of the oxides on steels in the reactor. And I enjoyed the project an awful lot, and my supervisor told me down the road there was a PhD in materials that looked at a very similar topic. So I just went and did what I enjoyed. So I did a PhD for, by the time COVID was over, 5 years in PWR materials and trying to make them safer for nuclear environments. And then stayed on to do a postdoc and disseminate some of that research and learn more about the area. When I decided it was time to leave academia, I went to a small company called Multex Flex. Multex Flex is trying to develop a novel molten salt reactor concept. So it was a small advanced modular reactor, and there was a lot of materials challenges, not as complicated as the ones in fusion, but still, how do molten salts react with your materials? What do your neutrons do to materials? What are your radiation effects? So there's a lot of really interesting challenges there, which really kept me interested in loving my job. Unfortunately, Multex didn't get funded in the UK to continue our research. So a couple of years ago, or just a year and a half ago actually now, looking for a new job after being made redundant. And again, it was kind of, okay, well, where can I stay close to home? I set up a good base, but where can I continue doing things with a variety and stuff that I was interested in? I think that's really what's led me throughout my career, is what interests me, what do I find exciting? And so I work in a small team in Amentum, which Amentum itself is a 55,000 person company. But I work in a team of about 25, tackling novel material challenges, supporting a mix of existing nuclear, advanced nuclear and fusion projects. And I'd actually not actually even joined the team when they put me forward to attend fusion school, hosted by Ella and those at York University. And within 1 week of finishing fusion school, October last year, I actually started here at UKFE on secondment. And I'm doing now part-time at UKFE, part-time at Amentum. And here, as I said, I'm doing the database lead. So looking at how do you ensure life cycle of your data from test data all the way through to plant operation and extended life. And it's not just about having good data today. It's about ensuring that we know future generations of reactor will have that data to build on to make sure we always have a safe, reliable operation. So if you're going through your career journey at any point, my biggest recommendation to you is choose something that you're interested in, choose something that makes you happy. So a little bit about why materials matter in fusion. So I really liked what Ciara said. We're making a sun in a box. And that's a really great analogy. But so where I come in is, okay, what are you making the box out of? And that's really, really challenging when you think about fusion, because you've got your high heat, 700 degrees Celsius for the materials. We're not talking about plasma, millions of Celsius, but actually what your steels are going to see. You've got high radiation with multiple displacements per atom throughout its lifetime, particle and neutron bombardment, and all your hydrogen isotopes floating around. So you have an awful lot of challenges to tackle. And there's no environment in the world that actually is equivalent to this. So you can't just test it and see how it goes. You have to take lots of different data and put it all together like a puzzle. And I really love working with puzzles. So it's an interesting challenge to see, okay, when I think of all the bits, do I have confidence this will work? So can I be convinced it'll be safe? It'll last as long as it needs to. It's not going to cost an outrageous amount because we actually have to build these. We want them to actually be a sustainable solution going forward to provide green energy for the world. And that's no good if we can't afford to build them. And then is it sustainable? Are we making the best choices? And throughout that, it's not just one material for the box. As you can see in the photo in the corner, there's lots of different components and they all have to fit together. So you've got plasma facing, structural, breathing blanket, insulators, coolants, all of them need to mix. So how do we really go about that? And that really interesting question is what keeps me enjoying coming to work. I don't necessarily even always do the material research, but through my job working with lots of people, I get to hear about it all. So my actual role is not doing necessarily all the really exciting fun science. I'm not sat in a lab testing things. I'm trying to take all the fun science everyone does, very sensible science as well, it's not just fun, and bring it together, making sure that everyone is working to a defined system, that we've got the right quality of data, that everything is done in time. We're not repeating work. So your data journey is you capture the material, you actually have to go out and get it, and you understand, what is it you've been testing. You just see, is it the right quality? Have we done the right assessments on it? You have to put it somewhere so that everybody can access it. So your engineers, designers, everyone can go about doing it. So it's a really collaborative piece of work. you apply and use it and making sure it goes into all your designs in the right way. But then continuously you're getting more data, more reviews, new designs, you're making different decisions. You have to review it and keep evolving it. So getting all these solutions to work together is really, really important. And my day-to-day, the biggest thing about my day-to-day is I'm talking to people who are absolute leading world experts in so many different areas. And I need to not just be able to have a conversation with them, but really pick out and understand what it is their needs are, what they want to actually achieve with it, to make sure I can bring everyone together with single solutions to make sure everyone's working in standardized processes. So I get to lead the development and management of databases, ensure quality, I get to do an awful lot of governing access, making sure that we fit the wider business infrastructure to make sure we're all following the same playbook and such, we all come together in the right way. So I get to work across with lots of engineers, scientists, data owners, QA teams, senior step officials, and make sure that everything comes together in the right way. And when we all do work together in the right way, we have a really high quality set of data that's provided that can actually help support STEP and make sure it comes to market in an appropriate way, which is really important. We're all trying to achieve fusion. And it's important that lots of different companies are doing this in different ways to make sure we get the best possible outcome. But it's a hard challenge, however you come at it. So making sure we're working together is absolutely critical. And making sure that the data we have to put into that is of top quality. My slides now. So why do I find this exciting? Why do I love doing what I do? Well, it's cutting edge technology. We are at the forefront of understanding, development, and research. And we're working with materials that haven't even been properly discovered yet, making new steels, making new tungsten composites, and understanding how do they behave, how will they work in the reactor. So I find that really exciting. So that's a really great part of my job. I'm also tackling real world challenges, so actually trying to solve a problem. We are in an energy crisis. We are struggling to have green energy affordably globally. So actually having a positive impact and making sure that it's an actual challenge you're addressing, not just doing research for the sake of research, which can lead to great results. But here we have a purpose and a goal and something we're aiming for. And it's really nice coming to work and knowing that if we're successful, we'll have a global positive impact and really improve things. So that keeps me excited. And hopefully a lot of you can find things that resonate there and choose something in your career that gives you all of that as well. So as a last just quick aside, I am on the committee of the Nuclear Institute Fusion Special Interest Group. It's a bit of a mouthful. We used to be the Next Generation Fusion Network. And if you're more interested to hear more about fusion, hear about more webinars and interests, I just really recommend you find our LinkedIn or find the NI Fusion Special Interest Group link and join up, because we advertise and make sure we do lots of different events to reach people like you to find out more about fusion and share the knowledge. So thank you, and that's everything from me.
Okay, thank you very much, Ciara. So we have one more speaker. Just a quick reminder before I introduce him that we do have the Q&A function, and it will be the Q&A session after the next speaker. So get your questions in to have the best chance of getting them answered. So on to our final speaker. So we have Ricardo Cortés. His current role is at UKAEA as an engineering analyst for MassDew and STEP Tokamaks, using engineering simulation tools to develop thermal structural models for in-vessel components influenced by heating and current drive systems. Additionally, he is developing design and low-fidelity simulations for the design of the STEP diverter dome. His previous roles include the oil and gas and automotive industries and the MSc in fusion energy at the University of York. Ricardo will tell us a short story of his career transition into fusion and give us a quick taste of the projects he's working on in microwaves and diverters from the engineering perspective. So, here's Ricardo.
Thank you. Thank you very much. Just quickly share my screen here. Okay, so thank you very much for the interest, Steve. So I'm having the big challenge to talk about fusion, my fusion career so far in a very quick way. So here's my career background. I
also, as many of the speakers, I don't come from fusion all the way. So I did my bachelor's degree in mechanical engineering. I also have some experience in oil and gas industry. I studied in automotive industry as test engineer in verification and validation. And then I just decided to turn my career 90 degrees and say, why don't we go to make some fusion? So I dropped into the MSc Fusion at University of York, great program. And then I took a placement at Tokamak Energy, and then I'm now working at UKAEA as an engineering analyst. So why did this change? Well, mainly it's purpose. I find that engineers and scientists, we all have a lot more power than we think, and we can decide what to build, what not to build, what to support. So this is very important for me, and I found fusion a very relevant field to apply this purpose and to have meaningful impact into this world of today. So what do I do today? So I get to work in a very nice office in Column campus, which is great. And I do engineering design and simulation for both the MAST-U and the STEP programs, this big tokamaks. So I find this a perfect blend, between engineering and physics. Very difficult physics and very difficult engineering because there's a lot of background that is not set yet. And this is where it gets very cool. Very, very interesting. So I get to play with tokamaks, and maybe some of you know it. And I know Steve has intro the fusion stuff. So among many things, is these monstrous devices need two things: a lot of heat input. You need to put a lot of heat into them, and then you also need to get rid of a lot of that excessive heat. So that's very challenging from both sides. So some of the projects that I am involved in is, first of all, in the heating and current drive with the EBW, which stands for electron-Bernstein waves, which is a method for heating up the plasma. And then the neutral beam injection system, how this create thermal loads inside the vessel, and how we can analyze how those loads will impact these components inside the vessel. In another project, I'm working on a step diverter dome design, which the dome has a purpose of improving the neutral's flow through the dome to improve the helium pumping. So this is a very critical component inside the diverter. And then in another project, I do simulation of irradiated materials, how this will behave after they are irradiated, and doing some correlation models, parameterization models on FEA models to understand and predict the stresses of these materials. So talking about the first one, so we know that there's primarily two ways of heating up the plasma, using microwaves or just shooting neutral particles into it. But when we do this, there's a lot of things that can happen. So when we shoot microwaves, the plasma has a density, and when it reaches a specific critical density, then some of that particles can be reflected back. And if they are reflected, then some of that energy would be scattered down through the vessel. And then if we shoot particles, because we want to heat it up, depending on the density of the plasma, again, some of the particles will shine through it if it's not dense enough, right? So if those shine through the plasma, those can also impact the in-vessel components on the other side. So all of this can generate a lot of heat and damage in-vessel components. So part of what I do is analyze this in-vessel and plasma-facing components from a structural and thermal perspective to make sure these withstand these very harsh conditions inside the machine, using some FEA models to understand how this heat will go through the different components, and using predictive parameterization models for these different thermal loads. In another side, the diverter dome is, I cannot show a dome from the step because it's still a kind of a in the IP scenario. So I added this ITER diverter dome picture, which you can see that is already in development and being built. So this dome, as I was saying, is its job is to improve the helium pumping in the diverter and avoid contamination in the plasma. So what I do is building some 1D cooling networks models for the step diverter dome to understand how much do we need to cool it down, to maintain the plasma facing components at the right temperatures. And because we don't have a complete design yet, we need to rely on models that are quickly iterative. So unfortunately, time is short today, but I really want to share the fact that we need more brains. So fusion is a huge challenge. A lot of things are not yet done. Many other industries have very well-defined procedures, validation plans, regulations, design rules. So in other industries, this is all well set in stone somehow. In here, we're building some stuff from scratch. So there's a lot of challenges that are awaiting. Massive investment is taking place all over the world, and it's really a great time to join the fusion industry and to be participating into it. So thank you very much for the time. I will be pleased to answer any questions, or in the future, if you want to address them to me, I'm all ears. Thank you.
Excellent. Thank you very much, Ricardo. So we will come on to the questions in just a moment. I did have one slide that I wanted to show before we do that. Just share this screen. And I can go to the next slide, this one. Right, so this actually maybe partly answers some of the questions that we've had as well, actually. So there was a couple of questions about good places to look for fusion roles across the industry and how to gain visibility of roles that come up across the sector. So there's some ideas on this slide, as well as a bunch of other things I wanted to talk about. So yeah, ways to get involved. But I mean, basically, these fall into categories of educational opportunities and employment opportunities, and also professional networks. So just to go through the educational ones, so there's a massive open online course called Exploring Fusion Energy, developed by the University of York. There's the MSc in Fusion Energy Science and Technologies from the University of York, and there's some open days about that. There's various bursaries and fee reductions available to help with these courses. And in terms of PhD programs, there's the Fusion Power CDT and the Fusion Engineering CDT. So Ella, will we be able to share these slides with the participants? Because I've got the links on the slide to all these things.
That's my plan, as long as all our speakers are okay with it. Yeah.
Yeah. Okay. Well, I mean, you can definitely share this slide. This is designed to be shared because it's got all the links for everyone. So yeah, the links are there on the slide to all these different things I'm talking about. Ella and/or Massey, do you want to say anything more about the MSc or anything else at York?
Yeah, I've got a quick slide if that's okay to share.
Yeah. Yeah.
Steve?
Yeah.
Sorry. Sorry, my thing is being a bit of a pain. Just going to restart that share. Why?
Yeah, it's come up now.
Sorry. Yeah, Google Docs is being a bit of a pain. There we go. Oh. Okay, so I just wanted to mention very quickly, we have redeveloped so University of York has had a fusion MSc for quite a number of years now, I think over 15, but we've redeveloped it for this coming intake in 2026 because we've noticed that we don't just need plasma physicists, we need engineering, we need data science, we need project management. So the new MSc programme will have sort of learning routes for all of those pathways. There'll be some modules that you do together as a whole cohort to understand fusion as a whole. And there'll be some optional modules related to your chosen pathway, which will have case studies from fusion. There'll be visiting experts and there'll be team projects. And I've really got to plug that we've got some open days coming up very soon. So if you're interested in finding out more, please sign up there. I'll send this to you after the event. I also wanted to just let you know there's a load of, I've got a list of other MSc programs that are around the UK if anyone's interested. I'll send those after the event, I think. On to questions.
Okay, thank you very much. I'm just going to go back to that slide that I had a moment ago, because again, it partly answers this question about visibility of roles. So yeah, so I talked there about the educational opportunities. There's also the professional networks. So yeah, there's FuseNet, which is the European Fusion Education Network. There's the University of York Fusion Society, which is a student society. They have a LinkedIn and an Instagram page. I can't see the next one because it's under my sharing bar. Oh yeah, I can't remember the name of it. You'll be able to read it on the screen. But it's like a collaboration amongst all the different student fusion societies from different universities. So if you're not at York, then you may still be able to get involved. We've already heard mention of the Next Generation Fusion Network, which has now become the Nuclear Institute Fusion Special Interest Group. There's the Fusion Industry. So this is kind of now back to educational opportunities. So there's a Fusion Industry School if you want to learn more about fusion and you're already working in industry. There's the Cullen Plasma Physics Summer School, which is a 2-week course that people can sign up to. So now actually coming to the question properly for roles in the sector. So in terms of job vacancies, I've got the links there on the slide to the UKAEA, Tokamak Energy and Amentum careers pages. But of course, there's many other organizations as well for which you can search online. So in terms of general advice of how to gain visibility of roles that come up in the sector, I would say become familiar with the different organizations that are involved in fusion and keep an eye on their career pages. You know, there's different national labs around the world and there's different private fusion companies in the UK and other countries. So find out what those organizations are, keep an eye on their career pages, and also try to connect with people. Like you can connect on LinkedIn and through webinars like this and conferences, all sorts of different events where you can connect with people who are working in the fusion industry. And especially if you've got LinkedIn, you know, people are advertising jobs on LinkedIn all the time. So that's the main answer I would give to that. Also, just to finish off the slide, we've got the UKAEA internships, so you can contact Early Careers for more information about that. Does anyone on the panel have anything to add about advice on getting visibility of roles that come up in the sector? No? Okay, I think we've answered that one then. So on to the other questions. So I'm going to go from this one. Given the extreme environment of fusion machines is pretty rare, especially the extreme EM environments, how has it been to transitioning from a mech eng or other training into having a deep understanding / modeling of the fusion industry's needs? Okay, anyone want to take that one? Yeah, Ricardo?
Yeah, I can take it. Yeah, so I think it's a real challenge because as I also mentioned, some of the procedures and the design rules are not yet developed for some of the components, right? So a lot of it is trying to develop models to predict what's going to happen. But the other complicated thing is the low availability of prototype testing that you have on the real harsh conditions. So yeah, it's a real challenge, and a lot of we can learn from other industries because a lot of the skills are transferred and the models that have been done before. But you need to step up a little bit and try to understand predictive models to the questions you want to answer. And a lot of it is understanding how to extrapolate things and use models to predict things that you have not found yet. Right? I hope that answers a little bit.
Okay, that's great, Ricardo. Thank
you. Can I build on that?
Yeah, go for it.
I think it's quite a nice transfer because you always go from your mechanical engineering, which is basically how things move with forces, and then magnets work when you've got opposing current. So at 90 degrees, you get a force, and then it's just understanding how the coils are working, and then it just goes back to your natural mechanical understanding. It's like, if that's pushing there, is this the sort of forces and loads that I'm getting? It's like, it is another bit of knowledge you have to bolt on, but all knowledge is subjectable, and then you'd add it to like Cara's, like, so her neutron damage for the materials, it just weakens the materials at that sort of section, and your neutron engineers will be able to tell you the sort of damage you're looking at the different materials. And it's materials engineering and mechanical engineering are linked. So it's just, you just have to learn about using certain softwares to pull the forces onto your models. So I don't think it's a massive jump, if I'm perfectly honest.
Okay, thank you for that. Okay, we've got a few questions to get through, so I think I'll go on to the next one now. So I think this one is a question for Ciara. So, which Amentum office locations have fusion teams? What are the key advantages of working on, for example, UKAEA or Tokamak energy projects from a consultancy like Amentum compared to working directly for the client organization instead?
So first part of the question, obviously, so our main fusion team headquarters are down here actually on the Culham site for UKAEA. So that's where they are based, but actually our fusion team is spread all over the UK. So I generally live up near our Warrington office, and we have fusion team members up there, but we also have people up in Glasgow office near them. We offer a hybrid working, so you in the office a few days a week, on site a few days a week, and we do have some totally remote engineers as well who are purely computer based and actually don't go into any offices except for occasionally for a team meeting, maybe once every few months. So as much as the focus is down here in Oxford, where I am today, you don't have to be here all the time. So it can be flexible based on what role you're doing. If you're a lab-based role, that flexibility does obviously disappear, but we try and work it where we can. So there are, I think, pros and cons, obviously, to being seconded in as a secondee. Wow, gosh. So my main ones is I still get to work on different projects. So I am here UKFE some of the week. I also still work on AGR projects and advanced reactor projects back up at Amentum. So I get to do a little bit of everything. So it keeps me really interested, engaged. It is all about that spinning plates and having lots of different things on the go at once, which can be difficult. But the variety is what I really love in my job. There is the negative trade-off is I don't always get to pick exactly what project I'm going to work on. I don't get to choose a role and say, I want to do breeder blanket materials. You know, a lot of the time people will directly employ if they can, and they'll come out to look for us maybe with some of the roles that they can't directly employ for, or they just want to be short term. So you get variety, but not always the same flexibility direction you want to pick. If I'm also being really brutally honest, it's private sector versus public sector. Sometimes it's cost of pay and bits and pieces like that, but the UKAEA pension scheme is top notch. So you get benefits wherever it is you work for.
Okay, thanks very much, Ciara. And the next question is probably for Sarah. So, how do you think the skill set and qualifications differ between a project manager doing large engineering projects and a more generic project management role? And you're on mute, Sarah.
That was actually what I was asking. I couldn't find the button. That's a really, really great question, whoever asked that. You know what? My journey into fusion is one to kind of explain that, really. I come from a standardized, just a standard project delivery background. I know traditional project delivery. I know agile for IT. You know, as I said, building rail, building film studios. For that kind of stuff, there's a lot of data out there. So when when you're delivering a project, you're trying to create change, new product, new service, etc. And you have a lot of certainty, or a good level of certainty, if you're doing some of those minimum viable product agile ones. However, when I came to UKAEA, and part of my role as head of profession is it's the complexity and diversity of trying to create fusion. So there's also a whole huge section of fusion, which is first for kind R&D and engineering and science. And for those, the delivery model is different. You still have controls, but you have low controls rather than the full throttle controls in terms of the way that you're delivering them, because you need to be able to, I call it a ping pong effect. It's like a ping pong table. You're doing loads of R&D projects within fusion at the same time, and at that portfolio level, you're putting more money on the ones going well, where they go, oh, that worked. And then you're starting to can some of the ones not working, but you're still backing, like I mentioned Liberty earlier, you're still backing some of those final pieces of the puzzle that we really need, even if you're still ping-ponging along. The mindset, okay, the mindset of a project professional delivering those R&D ones, and we've learned this the hard way, actually, if I'm perfectly honest, in the earlier days, you have to be really comfortable with rapid change, large levels of uncertainty, and working with that research community. And the worst thing to do is to wrap around it and assume that it's just a traditional way of delivering another project, because it's not. And so, and I can see some smiles and nods. And I've actually had to do a lot with the organisation, and I work with some other organisations now to make sure that works well. So it's to do with the delivery methodology, but it's also going back to those skill sets earlier. It's about knowing and honing in on some of those key softer skill sets and actually understanding from the technical side of our profession, the requirements capture, the financial management, milestones, blah, blah, blah. Sorry, those are all super important stuff, by the way. That actually the way in which you do the technical side of our profession is different when you're dealing with some of the stuff we deal with in fusion, and it has to be different. Otherwise, going back to that race to fusion global position, we'll go too slowly. Hope that helps, but it is and it's been an eye opener, by the way, for me coming here, because that's an element of our profession that I'd never. Bear in mind, my background is research and science, but actually I then went straight into the project profession, so I never really landed in this realm before. So I find that some of the strongest and greatest project professionals are actually ones with engineering and scientist backgrounds for some of those works, because their mindset is just used to that rhythm.
Excellent. Thank you very much, Sarah. So we're pretty much out of time, so I'm going to try to wrap things up now. There is one more question, but we don't have time for it, so I'm gonna say it out loud. Maybe the panelists can answer it afterwards, and we can just give a short written answer and then distribute that with the materials. So the question is, what does a real day or week working on a fusion project actually look like, and what kinds of challenges do you personally deal with? So I'll leave the panelists with that one to think about, and we'll give an answer offline for that. So yeah, just because we're out of time, I'm just going to wrap up with one slide that I've got here. I'm not going to talk for long because we're out of time, but just to say it's a really great time to join the fusion industry, and we need to get more people involved, especially on the engineering side, project delivery and all the rest of it. So keep in touch, stay engaged, stay positive and optimistic about looking for those opportunities, and we hope to hear from you again soon. So I think we'll leave it there. Thanks very much. And thank you to all the speakers as well. Thank you. Bye bye then.